Hi, it's Jack Kaluki from Nitrix, and in this video I'll describe how post-oxidation works on nitrided and nitrocarburizing surfaces and what are the benefits of post-oxidation. First, there are many confusing names for post-oxidation, and similar techniques are used without previous nitriding, such as bluing or black oxide. All of them relate to the creation of oxide layers on the steel surface. When we think of oxidation on steel and iron, the first thing that may come to our minds is rust. Rust is a form of iron oxide, but only one of the 16 known forms of oxides. Some iron oxides are used as magnets, others in jewelry and pigments, while some flow in your own blood. The oxide we create after nitriding or nitrocarburizing is called magnetite, the chemical compound Fe3O4. It is found in nature in the form of very hard magnetic crystals. Contrary to red rust, it is hard, compact, and resistant. The sequence of a typical process first follows nitriding or nitrocarburizing. During this stage, we produce a quasi-ceramic skin on the surface of steel parts. It is generally called compound or white layer and may contain approximately up to 10% nitrogen per weight, combined with iron and other elements. It is very hard, resists friction and corrosion. At the end of this stage, the process adjusts to the correct temperature for post-oxidation. Magnetite is produced in a very narrow range of temperatures and a specific amount of oxidants. Once the components are at the desired temperature, we introduce an oxygen carrier. It can be water, water vapor, or nitrous oxide. There are several different ways of oxidizing surfaces, and each one requires a controlled time and temperature. The process can be also controlled using an oxygen probe because excessive oxidation will lead to the formation of unwanted oxides. At the end of the process, you should achieve the desired thickness of magnetite. As you may have guessed, real magnetite layers are never thick because the oxide's claim to fame is to prevent corrosion, oxidation below the layer. It is compact by nature, and being compact prevents its own growth. Under ambient pressure and in the correct range of temperatures, Fe3O4 magnetite can grow to approximately 2 microns or under 0.2 of a thousandth of an inch. By increasing oxidation time, you increase the chances of creating unwanted oxides. These are less compact and will not prevent corrosion. Despite its thin appearance, a post-oxidized layer has unique and valuable qualities. It improves corrosion resistance, lowers surface tension with the presence of oxyhydroxides, lowers roughness levels obtained after nitriding or nitrocarburizing. It will also lower the friction coefficient. And also, a post-oxidized surface will look great when oiled with a very dark black finish. No wonder post-oxidation has many applications in hydraulics, armament, automotive industry, or in mining equipment. Click on the screen right now to watch another video on nitriding and nitrocarburizing. Make sure to leave a like or comment and subscribe to our channel. Thank you for watching and see you in the next video.